Okay, hi student. Today I want to continue our lesson. That's chapter 6 because we still not yet finished. We are until chapter 6 also, but 6.3 only. So today I want to continue 6.4. That's about the lenses. But I want to introduce a formula for this subtopic. Okay, let's see the formula for this subtopic. Okay, this topic, there's a thin lens formula. So I need to introduce the three physical quantities to create the formula. Okay, first one, there's a relationship between the three physical quantity. There's an object distance by using the symbol, there's a U. Image distance, there's a V. And the last one should be the focal length. Okay, focal length for the lenses. Okay, now we go and create three physical quantity become one of the formula. That one we call it lens equation. Okay, let's see the lens equation. There's a 1 over F equal 1 over U plus 1 over V. Okay, when you do the calculation, we're using cm. If they give you meter, that means you need to convert, they become cm. Okay, we go the next one. Okay, this one is an effect for the different lenses we're using. Okay, can you see the first picture? Position of the camera lens that close to the object produce a large image. So this one I think everybody know lah. When you just zoom, that means you go closer to the object, you find it, the image you capture, they become large. So the area becomes smaller. So you cannot see the far area. You just can see one of the window. Okay, now we go to another picture. This one is a position for the camera, for the object. Then they will go further. Okay, go further from the object. They want to capture the table. So now you can see the small image produced. The table size becomes smaller, but you can see the whole living room. Okay, you can see the whole living room. You can see the three window, and far away got one of the sofa, and also the picture. You can see the full picture, and also above the ceiling they got lamp. Okay, but for the first diagram you cannot see about that. So this one is a image formed by the different distance from the camera to the object. So you get the image also different sizes. Okay, so from this one formula we need to calculate what is the object distance. If you go to adjust your object distance and you adjust your focal length, then you get your image distance sure will changes. Okay, this one is an example for the low and also high of the aperture. Okay, this one low. When you see the capture become lower, the adjust become low power, you find it the image become closer. Okay, so if I make it become the high power, the lenses become larger. So you find it the image they capture is further. That's a bigger size. Okay, this one is a different lens. And also the different distance they go to adjust. Finally, they get the image size also different. Okay, let's see this one experiment. There's a 6.3 relationship between the object distance and image distance. Okay, first one, the inference. Image distance is influenced by the object distance. So from here means the image should be the responding variable. Object is a manipulate variable. That means we control the object distance. Okay, hypothesis is when the object distance just increase, the image distance is decreases. So this one is earlier of the conclusion we make it. So that means when we just adjust the object distance, you find it, the image distance also change. But when the object distance increases, the image distance will be decreases. So this one should be inversely proportional. Okay, then we go see the aim. Aim, you need to mention relationship between the object distance and also the image distance. Okay, variable, object distance, that should be the MV. RV is the image distance, then the focal length will become constant variable. Okay, now we see the apparatus. Okay, what should be important apparatus means the thing you want to measure the MV and RV. Okay, you must have the convex lens. This one should be the important. Okay, the second one, the lens holder. You want lens holder, no lens holder is okay. Then you're using the bulb. Okay, bulb will become the object. Wooden block just make the bulb higher, or you want to make the holder become higher. Okay, after that we must have the power supply. Okay, power supply, you want to supply for the bulb. Okay, cardboard with the small triangle. After that you got the shape of the hole. Okay, wide screen, you must have the screen. So from here I zoom. Okay, wide screen is important. And the last one that's important should be the meter rule, because meter rule they want to measure the length. If you just miss the meter rule, that means you cannot function the whole experiment. Okay, we continue for the procedure and diagram. Okay, set up. So the first one you must say you set up. Okay, set up apparatus same like the figure below. Okay, we got bulb. Okay, this one is cardboard with the triangle. Then the lens must put at the middle. Then the screen is behind. So this one we measure as an object distance from the triangle holder until the lens. This one is an object distance. So from the lens go to the screen, that one is a image distance. Okay, first you set up. Number 2, you must say switch on. Okay, because you mentioned PowerPoint in the apparatus. So number 2, you need to say switch on. Not switch on, that means the bulb cannot on. Okay, when you just switch on the bulb, you need to start experiment. So you mention when starting your MV is how many. Okay, when you just MV how many, 15.0 cm, that one is a manipulated marks. Okay, number 2, you cannot say straightforward you go to record the reading. You must say you adjust. Because when you set the object distance, you cannot straightforward you get the image. You need to adjust the screen until you get the sharp image. So the word I highlight by using the red color, that one is a keyword. Adjust the position of the screen until you get the sharp image. Okay, number 4, you go to measure your image distance by using the meter ruler. Then after that you record your readings in the table. Okay, number 5, you need to repeat. Okay, we need to repeat the step 2 to step 4 for the object distance. Then you need to mention what is your object distance. If just now is a 15, so now at least you need to repeat 4 set. Okay, when you repeat the 4 set, you need to mention out. Okay, cannot just say repeated 4 set. So you need to list out what is the 4 set, 20, 25, 30, and 35 cm. Okay, after you get all the repeated finish, then you need to drop down inside the table form. This one is the result. Okay, for my student, they do the experiment. So this one should be the result. Okay, can you compare the U and V? When the U keep increasing, the V is a decreasing. Okay, now we do the calculation 1 over U. Okay, from here I get 3 decimal point. So if you get 3 decimal point, that means every reading here must be consistent decimal point. So 0.067 mean this one 0.05, you need to add 1 more 0 behind. So this one become consistent. So 1 over V also the same thing. So 0.017 until the end also is a 3 decimal point. Okay, then we see the next one. They want you to plot the graph 1 over V against 1 over U. So when the question just mentioned like this, 1 over V, the first one against the second one, the first one there's a y-axis. The second one sure is a x-axis. Okay, when you start to plot, you need to see the reading first. For the 1 over V, the smallest is 0.017. The largest is 0.045. So normally the scale, because the graph you need to draw full graph, you cannot draw a small size. So from here 0.01, that means we always start from 0. We start 0.01, then 0.02 until 0.05. That one is your range. Okay, for the U, also same. The smallest is 0.029, maximum 0.067. So we also start from 0. So the first reading must be 0.01 until 0.07. Then you can include all the readings. Okay, let's see the graph. Okay, this one is a graph I plot already. Okay, this one is a 1 over V. This one is a 1 over U. Okay, when you just label U and V, that means the y-axis and v-axis is a symbol. That means you get 1 marks. Okay, the second one is a symbol, the unit, sorry, there's a unit. Okay, unit is a cm per 1. Okay, c, then m negative 1. This one also same. Okay, the scale I start from 0. So this one is a y-axis. So this one is a x-axis. So every point I go to plot. Okay, after that I draw the line. So can you see I cannot touch? I cannot touch all the point, but at least I can touch 2 points. Okay, as I touch 2 points, I want to make it, is it best fit? Okay, best fit means up and down should be balanced. So you see I got 2 left below, 1 left up. So this one we call balance. Okay, now the question 2, they call you determine the gradient. So when they determine the gradient, you must draw the triangle. So the triangle here, you must draw at least, okay, 4 times 3 boxes. 4 means what? 4 means 2 cm. 2 cm is a 1 box. So 4 means at least you got 8 boxes. Then up is a minimum 3 cm. Sorry, it's a 3 boxes. So should be 6 cm. So this one is a minimum size. So I draw already this one. Can you see the red color? Okay, I put one perpendicular. Then this one is my coordinate. So I take this point and also the last point. So from here, okay, we want to determine the gradient. So we show the formula first. Okay, let's see the formula. Okay, for the graph, the gradient m equal, normally it's a y1 minus y2 over x1 minus x2, is it? Okay, now I put the calculation. 0.075 minus 0.015. Okay, that's a y1 minus y2, x1 minus x2. So I get the answer, there's a 0.923. Okay, that's a no unit. Okay, then we go to determine the intercept for the both axes. So both axes mean you cross the y-axis. Okay, this one is cross the x-axis. So normally you draw it, become longer a little bit. So when I cut here, I can read the reading. So my y-axis should be 0.075. Okay, when I cross the x-axis, I also need to read. So my reading is 0.075 cm negative 1. Another one is a 0.081 cm negative 1. So these all the answer will refer your graph. Okay, now we're using the length formula and the graph plot. We need to determine what is the focal length, okay, of the length in this one experiment. So first one, we're using the length equation. 1 over f equal 1 over u plus 1 over v. Okay, now I want to move the position. Okay, I move the 1 over v here. I keep here. Then I move 1 over u, go to left hand side. So you find it 1 over v equal 1 over f minus 1 over u. Okay, when the 1 over u go to left hand side, they become negative. Okay, now I continue to move. Okay, I want to move the 1 over u go in front a little bit. So 1 over v equal negative 1 over f. 1 over u plus 1 over f. So, okay, make sure this whole row you understand. I just move the position only. Okay, now compare the length equation. So this one is just now I move already. I want you to focus is a 1 over u. Okay, compared to the original, the equation we learned for the graph, y equal mx plus c. So y-axis is what? Y-axis is 1 over v for just now the graph. Okay, x-axis is what? X-axis is 1 over u. Okay, is it? So from here, can you see there's a 1 of the negative? Okay, this one of the negative means that one is a gradient. Okay, that is a gradient. So from here, we want to focus just this part only. Okay, x is a 1 over u already. Just a negative, that one is a m. Okay, that one is a m. So, and the last one is a c. C is a 1 over f. Okay, now we're going to see the negative 1. This one is a 1, is it? Because we never put the 1. So we can conclude m equal negative 1. Okay, later you find the gradient, sure it's a negative because they go downwards. Okay, then the next one, then there should be the c. C is a 1 over f. Okay, now we're going to check 1 over f. Okay, because just now we cut already. C actually is a y-intercept, is it? So that means 0.075 equal 1 over f. So from here we can find the f already. So the answer now, the focal length for this one, the lenses we're using, there's a 13.33 cm. Okay, we never do any calculation, we're just using the graph to compare two equations only. Okay, now we're going to see some information. That means the sign of the conversion, use the thin lens formula. Okay, this one is when you do the calculation, we get the info. Then from the info, we want to imagine, or you want to state characteristic of the image. Okay, first one, focal length. Okay, positive for the focal length, converging lens or convex lens. Okay, now this one is a negative, there's a diverging lens or you say concave lens. Positive is for the convex lens, always positive for the focal length. So for the concave lens, the focal length, when they just mentioned 2 cm or 20 cm, you must put negative. So important is the lens. So when you read the question, you must understood they're using what lens. Okay, when they're using convex, okay, you are safe, positive. If they're using concave, then you need to automatically put negative. Okay, image distance. Image distance is real image, positive. Because convex lens also can positive, also can negative. When you get the image is a real, the answer is positive. Okay, on the opposite side of the object. So the object is the left, your image must at the right hand side. This one we call positive image. So when you get the virtual image, so example you get the u less than f, that one is virtual image. When you get the virtual image, the answer should negative. So negative means what? There's the same side with the object. That means object at the location left hand side, your image must have the left hand side. That one we call virtual image. Okay, so make sure you understood positive and negative. Okay, I repeat again. Convex, focal length always positive. Concave, focal length always negative. Okay, image distance. Okay, for the real image, you get the answer sure positive. So where the location of the image must opposite direction with the object. Object at the left hand side, after you draw, your image must have the right hand side. Okay, negative image. Negative image means there's a virtual image. Virtual image, the situation is object and image must located at the same location. Okay, if the object is the left hand side, your image later form also as the left hand side. That one is a virtual image. Okay, remind back the last lesson we say part 1 and part 3, is it? So if I say a positive image, your object at the part 1, then your image must have the part 3. If negative image means virtual, object is a part 1, your image also at the part 1. That one we call virtual image. Okay, we try some example question. Okay, let's see this one question. The object height is 2 cm. Okay, they place 30 cm from the convex lens, focal length is 20. So when we start to do first, okay, we do count first. We write the info. So from here we know the object height 2 cm. Object distance 30 cm. Focal length 20 cm. So the first one, they want to find image distance. Okay, they want to find V. So we need to show the lens equation. Okay, this one is a lens equation. I want to find the V. So you put all the info first. Okay, 1 over 20 equal 1 over 30 plus 1 over V. Okay, important you see the F is a 20. I never put negative. Why? Where is the keyword? The keyword is convex lens. When I say convex, then you save. Focal length sure positive. So I write all the info. I need to find the V. I think until here there's no problem for yours because they want just a calculation for your max. Later you need to reverse. I just want the V. I don't want 1 over V. So from here I show you the calculation. 1 over V equal 1 over 20 minus 1 over 30. Okay, the rest you go to solve by yourself. Final answer for the V is a 60 cm. So when you see my image is a positive 60 cm. So this one sure is a real image. Okay, so this one convex lens, I get the rear image. Remember, rear partner is who? There's a inverted. Okay, then we can compare about the size to find the magnification. Okay, let's see B. Okay, B, they want to find the linear magnification V over U. So V is the image distance. Just now we find this 60. Object distance 30. So I get 2. 2 means what? Then more than 1. More than 1 means you are magnified already. Okay, because you get more than 1. If you get 1 means same size. If you get 0 point something, they want is diminished. So I get 2. So the answer should be magnified. So my characteristic actually is come out already. There's a real, inverted, and magnified, is it? So I need to prove some more. I want to find the image height. The image height sure more than 2 cm because you said you magnify. Okay, now we go to find it. Okay, this one is your magnification, HI over HO. So HI we do know, HO is a 2. So final, I get it. The HI is 4 cm. So I prove already. Image height more than object height. Okay, last one, characteristic. Rear, inverted, and magnified. So this question is no need to draw. We're using the calculation, then we can find out characteristic. Okay, now we go to second question. Okay, I already underlined boxes. The keyword is a concave lens. So when they're talking about concave lens, you must be careful. Okay, let's see the info. HO 6 cm. Object distance 20 cm. Okay, now the question never give you the focal length. They give you the power. So the power you need to put negative because there's a concave 2.5 diopter. So the first step we need to find focal length first. Okay, so I show how to find the focal length first. P equal 1 over F. So I put negative 2.5 equal 1 over F. So I need to find the F. When you find the F, there should be negative also, but that's an emitter. So better you go to convert, become negative 40 cm. Okay, so I get the F already. So the first question I want to find image distance. Same like the just now formula. Okay, so I straightforward to convert negative 1 over F equal 1 over U plus 1 over V. So I go to adjust. Okay, now 1 over V equal negative 1 over 20 minus 1 over 40. So after do the calculation, I get my answer for my image V. Okay, the V sure negative because they're using concave. Concave just got one type of characteristic. The sure is a virtual. So my answer, I get it, 1 over V equal negative 2 minus 1. So over 40, so the answer is a negative 13.33 cm. So that one is a virtual image. Remember, virtual, the partner should be upright. Okay, now I want to prove, is it diminished or not? So I need to find the image height. Okay, we see the B. Now the B, we need to find out the image height. Okay, from here, we need to find magnification, then we can find the image height, is it? So I show you the formula. M equal V over U equal HI over HO. So from here, I need to find HI. I need to find out V over U first. So you take the V, there's a 13.33 over 20. Okay, because for magnification, we don't have any negative. So we just ignore. So we get it 0.667 multiply HO. HO is a 6 cm. So I get 4 cm. Okay, so from here, I make sure there's a diminish. Because object height 6 cm, image height just 4 cm. So they become smaller. Okay, now they want to find the linear magnification. So it's the same thing. M equal HI over HO. There's a 4 over 6, 0.67. Okay, if you don't want to using this one, you can using V over U. It's the same answer. Okay, last one, characteristic. There's a virtual, upright, diminished. Okay, let's see the example 3. Keyword, convex lens. Okay, when I'm just talking convex lens, that means you are safe or positive. Okay, let's see the info. Okay, for the first info, there's a A. Yeah? F is a 12 cm. Now the object distance is a 18 cm. Okay, the question they want to find, determine the characteristic and position of the image, form, and also linear magnification when the object distance like this. So you need to find three things. Okay, you need to state the characteristic, you need to state the image distance, then you need to say the magnification. Okay, we start first. Okay, we find out what's the image first. 1 over V equal 1 over F minus 1 over U. Okay, so from here I need to find out what is a V. So from here you do your calculation, straightforward you do it. So I get it, there's a positive 36 cm. So positive means there's a real together with inverted. Okay, now we need to find magnification. So magnification is M equal V over U. So V is 36, U is 18, so I get 2. So no unit, 2 is a magnification, means already more than 1. That one is a magnified. Okay, last one, I need to give the characteristic. So there's a real, inverted, and also magnified. So this one's for A, 18 cm answer. Now if I change the object distance become 4. Okay, now I write the info. Okay, 12 cm. Then after that is a 4 cm for the object distance. Okay, both also positive because there's a convex. Okay, again, I'm using the same formula again. 1 over V, 1 over 12 minus 1 over 4. Okay, now it's 1 over 4. Okay, final answer, I get it negative 6 cm. Negative means there's a virtual already. So understood, virtual, the partner should be upright. Okay, now we want to find the magnification. You want to make sure is it there's a magnify or diminish. Okay, let's see the calculation. Okay, M equal V over U. So V is a 6 cm. Just ignore the negative. Then 4 is a object distance. So I get 1.5 means still okay. They're still bigger than the 1. So the image must be magnified. Okay, so from here I conclude. Okay, if I get negative, there's a virtual. Virtual partner, there's a upright. Okay, magnification, I get 1.5, more than 1. So there's a magnified. So your characteristic, virtual, upright, magnified. Okay, so this one is refer the calculation, we get the characteristic. Okay, now we go to the number 4. I already key online, cut the circle here. There's a concave lens. So concave, you must put the negative by yourself for the focal length. Okay, determine the position and the size of the image form. Okay, so you need to mention the image size and also image distance and also the characteristic. Okay, so we write the info. HO image, the object height is 9 cm. Object distance 60. Then the focal length put negative. Okay, after that we go and find the formula. Okay, 1 over V equal negative 1 over 30 minus 1 over 60. So final answer, I get the V is a negative 20 cm. So there's a virtual image. Okay, now we need to find out the size of the image. Okay, so you can find about the image size. Okay, M magnification 20 over 6. Okay, because this one is a V, this one is a U. So I get it, the magnification becomes 0.33. So that means the size is become smaller, diminish. Okay, you also can find about the size of the image. There's a HI over HO. So you can get the answer. Okay, last one, I mentioned the characteristic. There's a virtual, upright, and also diminish. Okay, so this one is a formative 6.4 from your textbook. Okay, let's see the A, concave lens. Okay, focal length is 25 cm. They form the virtual image of the N at a distance 20 cm from the optical center lens. Okay, now we write the info. Okay, F is a negative 25. Okay, then the virtual image, they get virtual, so negative 20 cm. So what's the original position of the N? They want to find U. So we write the info. 1 over U equal negative 1 over 25. Minus minus become plus 1 over 20. So final, I get the object distance is 100 cm. Okay, so this one you need to count by yourself one by one. Because I short form, I straightforward press the calculator, then I grab the answer. Okay, when exam, you need to show the calculation that can help you to get the marks. Okay, number 2, you need to draw. Draw the ray diagram, the formation of the virtual image of the ant. Okay, so the virtual image of the ants means you need to create to show the virtual image, you get it. Okay, now I show the graph how to get the virtual image by using the concave lens. Okay, this one is a setup for the concave lens. Now your object is more than 2f because you are further 100 already. So I set up like this. My object is behind the 2f. So the first ray, remember how to draw. We draw the first ray. After that, you must from the f, okay, diverging. This one we call first ray. And the third ray, we straightforward go to center. Okay, now you can see the cross already. So this part should be your image. Okay, so from here, this one is a diagram. How to get the image from the concave lens. Okay, then we go to the following question. Okay, now the following, they show a bulb, small bulb. The distance is 1.6 meter. Okay, from the convex lens. Okay, convex. Focal length is 30. It's placed between the bulb and the screen. Okay, now you need to determine the two positions of the convex lens can produce a sharp image on the screen. So we write the info first. 1.6 meter is from the bulb to the screen. So I show for you. From the object until the screen, 160 cm. Okay, this one is a convex. So the focal length positive. So this one is a info. Still the info. F is 30 cm. Okay, V. V is how many? V is a 160 minus U. Agree or not? Because overall is a 160. So you want to find the V, must be minus the U. So that means you need to find what's the U first lah. Okay, now we go to do the calculation. Okay, let's see the calculation. The first step, I need to write out the length equation. Okay, this was a length equation. So I put all the thing in. 1 over 30 equal 1 over U plus 1 over 160 minus U. That one is a V. Okay, then I continue. Okay, 1 over 30. Okay, I want to make below the number should be the same. U multiply 160 minus U. Okay, so up should be cross. 160 minus U plus U. Okay, then I continue. This part, I move to left hand side. 30 go to right hand side. That means I cross to multiply. Okay, U bracket 160 minus U. This one 30 already is here. Bracket. Then this all must be multiplied to 30. Okay, now after I multiply, 160 multiply the U. U also put in, become U square. So now 30 is outside. Okay, then after that 30 already multiply the U. Okay, suppose when the 30 multiply this U, this one is a negative, this one is a positive. That means we cancel already. Okay, we cancel each other. So finally, this one is an equation. U squared minus 160U plus 4,800 equal to 0. So from here, we need to find what's the U. Okay, you need to create out. Okay, factor out what is the U. Okay, so from here, we find it after factor. U minus 120 bracket U minus 40 equal to the 0. So from here, I can conclude what's the position of the object distance. Okay, first one, U will equal 120 cm. Another one, U will equal 40 cm. Finally, you can get the sharp image. So this one is one of the hot questions. So hopefully you will understand about that. Okay, so our lesson just until here. The next one, I will discuss about the tutorial for this one 6.4. So hopefully you finish it. So tomorrow I will discuss about the tutorial. Okay, so just thank you for your watching.